Okay, so today our objective is to understand formulas for cylinders and cones. So this is the lesson 12.3. And first what is a cylinder, what is a cone, what about their formulas? Okay, so let's start with a cylinder. Can anyone describe a cylinder? Give me something that you know that is cylindrical in shape. We run across them very frequently in our lives. Dakota?
Can.
Yeah, any kind of can is considered a cylinder. So of the two shapes we've talked about, prisms and pyramids, what is a cylinder most like? It's most like a prism because it has a flat top and a flat bottom, and those two quote-unquote bases are congruent circles in this case. Okay, so it's like a prism, but the bases are circles. We're going to assume it is a right cylinder. And if you remember when we were talking about prisms, we had right prisms and oblique, Aiden. But unfortunately, we didn't have any theorems on formulas for the oblique ones, so we just concentrated on the right ones. So we're going to assume it's a right cylinder, where the segment joining the centers of the circles is an altitude, which measures the height of the cylinder. And that was true too of our right prisms. We could take that from top base to bottom base at any point, from the center of the bases, from the base edge. They all had to be the same number. And then the radius of the base, so the radius of the circle, is equal to the radius of the cylinder. So those two are interchangeable with each other. Okay, so I have two theorems, one on lateral area and one on volume. So the first one, theorem 12.5, says the lateral area of a cylinder equals, and that's where I'm going to pause for a moment and say, can you guys remember what the formula for the lateral area of a prism was? Yeah, just perimeter times height. Okay, not 1/2. That's talking cones, or talking pyramids. So it's just of a cylinder. It was the perimeter of the base times the height of the prism. Now this one doesn't have an area of the base, or perimeter of the base, because we don't have perimeter of circles. What do we have of circles that's like a perimeter? Circumference. So what we're going to do is take the circumference and multiply it by the height. Okay, so same formula. And because we aren't using, yeah, so that's basically all we're doing. So it's going to equal the circumference of the base times the height of the cylinder. So we've got lateral area is equal to 2 pi r times h. And again, we're using capital H to identify the height of the overall shape, whereas a little h might be the height of, let's say, a side. Okay, so that's, I'm making that distinction. The book doesn't make it. So again, keep this in mind. Perimeter is like circumference, and that's where the 2 pi r comes from, to replace lateral area equals perimeter times the height, which was the formula for the prism. Okay, so they're very related formulas. So this is the beautiful thing, is if you understand that a cylinder and a prism are very similar, if you only memorize the formula for a prism, all you have to do is substitute in what the perimeter would be for a circle, and then you've got the new formula. So it's not like you have to memorize all these separate identities. They're very related to each other. All right, so here comes the volume one. So theorem 12.6 says the volume of the cylinder equals, and then I'm going to pause again. What was the formula for the volume of a prism? Area of the base times the height. So what's the area of a circle? Pi r squared. So that's what's going to take the place in this one. It's equals the area of the base times the height of the cylinder. So we have volume is equal to pi r squared h. So remember, with the prism, B, h, what is the volume? And in our case, B is pi r squared. So we just substitute that in. So again, generically, all you have to know is the formula for the volume of a prism, and just know what the area of a circle is to substitute in for that area of the base. Okay, let's talk about cones. So what's something that you guys come across that is the shape of a cone? Yeah, well, you have to be specific. Sugar cone, waffle cone, okay? Not those old-fashioned styrofoam cones that my dad loves and I think are disgusting. The ones that have the flat bottoms to them. Oh, this is terrible. That's his favorite. Yeah, no, not me. So if you think about a cone, what shape does it most resemble that we talked about before? Pyramid, right? It comes to a pointy top, has a flat bottom. One flat bottom. So, actually, let's just call it cone. So a cone is like a pyramid. But the base is a circle. And again, we're going to assume it's a right cone. as opposed to a wrong cone. Okay. So I've got two theorems on these. One on surface area, one on volume. So what can you guys tell me about the lateral area of a pyramid? What was it?
1/3.
Nope, not 1/3. 1/2 the perimeter slant height. So 1/2 perimeter times the slant height. Well, what's the perimeter of our circle? It's the circumference. It's the 2 pi r. So that's going to get substituted in. So the lateral area of a cone equals half the circumference of the base times the slant height. So according to this, lateral area is 1/2, and we have 2 pi r, and then we have slant height, and the half and the 2 cancel out, and you have pi r l. Okay, and if you think back to of the pyramid, it was 1/2 the perimeter times the slant height. So it's the same formula, except for we plug in 2 pi r. The 2.5 cancel out. So again, not a formula you have to memorize. You just you have to go back and memorize stuff about circles. Okay. And by the way, if you guys didn't notice, I did grade your tests. They are in. I just didn't have time to sticker them this morning, so you'll get them back. And I'll tell you, the people who did well versus people who didn't do well. People who didn't do well didn't know their formulas, number one. Number two, didn't reduce their radicals. Didn't attempt to see if there was perfect square factors. That was a big thing. Dropped off signs, or like labels. And didn't recognize if you had a 30-60-90 or a 45-90, or created 30-60-90 out of nothing and a 45-45-90 out of nothing. Didn't recognize Pythagorean triples. Okay, so all those things, those background stuff, I said, well, you know, if you don't want to learn them, you don't have to, but I'm going to tell you it's going to help you. Kind of bit you in the bottom. So we'll get those back tomorrow. And then the volume. So, volume of the cone. Equals, now let's go back. And what was the formula for the volume of a pyramid? Okay, page. Okay, so it was 1/3 of the area of the base times the height of the cone. So the only thing that's going to change for us is what goes in for the area of the base, which would be what? Pi r squared, right? So the volume of cone equals 1/3 the area of the base times the height of the cone. So we have volume equals 1/3 pi r squared big H. So if you think back to the volume of a pyramid, I guess we should change that to an R. It was 1/3 the area of the base times the height. So the only thing we're doing is replacing the area of the base with the area of a circle. Okay? So again, there's no brand new formulas to know we just substitute in what we know about circles into the other formulas. So, let's see, I think we have time to do a mini example. So on your homework tonight, you're going to be given a chart, and it's going to have some missing pieces, and your job is to fill in all the pieces. So you have a chart that looks something like this. R for radius, H for height of that shape, LA, TA, feet. And they're going to give you a picture, and it's either going to be of a cylinder or of a cone. They're going to label this piece down here as R, this is H, and those are going to be at a right angle to each other. So, if I tell you the radius is 5 and the height of the cylinder is 10, what should I start trying to figure out? Can we do lateral area right now? Do I have enough information for lateral area? Yeah, I do. So lateral area is going to be the perimeter times the height, which is the same thing as saying 2 pi r h. So we plug in 2 and pi and 5 and 10, and we get 100 pi. Now total area is not a formula that they make a theorem out of because it's logic. Well, I have the lateral area plus I have the area of the two bases. So I'm going to get 100 pi plus 2 times pi 5 squared. So that's the radius squared. So 5 squared is 25. And then 25 times 2 is 50. So I get 100 pi plus 50 pi equals 150 pi. So that's the total area, volume. This is the one that was 1/2 times, or it's area of the base times the height. So we have pi r squared h. So we have pi times 5 squared times 10. So we get 25 times 10 is 250 pi. Okay. And what if I said, okay, how about if I give you the height is 12 and the volume is 192 pi? Well, I can't start with lateral area, and I can't do total area because both require R. So what I'm going to do is start with volume. Area of the base, pi r squared, times the height. And then I plug in what I know. So I have 192 pi is equal to pi r squared 12. So I'm going to divide both sides by 12 pi. 12 goes into 19 once with 7 left over, and 12 goes into 72 6 times. Take the square root of both sides, and we don't worry about the negative because we have a negative length. So now I have r. Okay, that is going to go into my first box. And now knowing that, I can do lateral area and volume pretty quickly. So we have perimeter, which is 2 pi r times the height. So I get 2 pi times 4 times the height of 12. So I get 8 times 12, which is 96 pi. And then the total area is going to be the lateral area plus the area of the two bases. So it's going to be the 96 pi plus 2 times pi 4 squared. So I get 2 times 16 pi, which is 32 pi. And that gives me 128 pi. Okay, so that's the kind of stuff that you'll be working on. Just given some information, figuring out what's the missing pieces, what do you need in order to figure out the other. And then again, you don't need to memorize special formulas. You just need to know the perimeter of a circle is 2 pi r, and that the area of a circle is pi r squared. Now, I actually did have somebody on the test confuse those and wrote the circumference as the area and the area as the circumference. Okay. A lot of people dropped off halves when it came to formulas like rhombus, area of a rhombus, and area of a triangle, big time. And then people would put it in on the area of a parallelogram, put it in half. So, again, you guys need to go back and really work on those Chapter 11 basic formulas because they are part of this chapter as well. All right, good luck with your homework.